These are the point slope form notes for linear equations, section 11 for honors math. So example 1, we want to review the formula for calculating slope and find the slope for the two ordered pairs given. So as you recall, the equation for slope was the change in y's divided by the change in x's. And so we said that slope equals the change in y, the y ordered pairs, divided by the change in x's. And that's the formula without context that can be related again back to a graph as you're calculating slope with rise over run. So to use that, remember that these ordered pairs are both x comma y, because we want to make sure that we get this all in the right spot. And so our slope would be 15 minus 8 over 9 minus 5. And so 15 minus 8 is 7, 9 minus 5 is 2. And so our slope here oops, I have a mistake there. Our slope 9 minus 5 is actually 4. And so our slope would be 7/4. So today the new topic is point slope. And so in addition to slope-intercept that we are familiar with, linear equations can be written in an equation called point slope. And this is the formula or the format. It's going to be y minus y1 equals m, or slope, times x minus x1, where m is the slope and x1 and y1 is a point on the line. So remember, slope-intercept is y equals mx plus b. Now we have point slope format as well. And so let's talk about how we could get point slope from the equation that we know about slope so far. So on example 1, we said the equation for slope is that m equals y2 minus y1 divided by x2 minus x1. So this y minus y1 equals m times x minus x1 doesn't come out of nowhere. It's mathematically true. And we already know that this slope equation is true. So what we're going to do is going to rearrange and get rid of this division problem that's happening, or this division portion of the slope formula. So the opposite of dividing by the change in x is we could multiply both sides of this equation by the change in x. So x2 minus x1, multiply on this side. And what you do to one side of an equation, you have to do to the other. And so we have x2 minus x1 being multiplied on the left side as well. So on the right side, numerator, denominator, those are going to cancel. And then we start a new line here. We would have our slope times x2 minus x1 equals, what we have left with over here is simply y2 minus y1. And now, if we wanted to rewrite our equation so that the y's are on the left side as in the equation here, we can simply rewrite this in the other order. y2 minus y1 equals slope times the change in x. Now, as far as our equation, let's think back to y equals mx plus b. This y and x, they never changed. You were always changing the slope and the y-intercept. That's what's happening here in this equation. Let me make this a little bit cleaner here. So the first y is never going to change. So I'm going to take off my sub 2. And my first x is never going to change. And so those two parts, this y here and this x here, they're never going to change. But you're going to plug in a slope and an ordered pair, x and y, just as you would plug in the m and the b and the y equals mx plus b. So let's go ahead and practice this a couple times. So we are given a slope of 3 and an ordered pair of 4, 6. So we have this equation, and let's write it down to practice. So it's y minus y1 equals m times x minus x1. This is straightforward plugging it in. Slope of 3 goes in the m place, the 4 goes in the x location, and the 6 goes in the y location. So we would write down y minus, and the y number is 6, the slope is 3, and the x is 4. So that's all you do to write the equation when you have the slope and the point. So our final equation here, y minus 6 equals 3 times x minus 4. Let's try another one. Example 4. This time we have a slope of negative 1/2 and a point of negative 3, 4. So again, plugging in to y minus y1 equals m times x minus x1. And the more you write it, the easier it will be to remember the equation. Plug in your negative 1/2 in for m, but notice now my x is a negative 3, and I'm plugging it into a minus x. So when we do that, x minus a negative 3, in this parenthesis here, minus a negative would simply turn into a plus 3. And so our equation would be y minus 4 equals negative 1/2 x, or 1/2 times x plus 3. And so this is now a positive in the parentheses because the negative ordered pair that was given to us here. All right, on example 5, we increase the difficulty a little bit just because now you have two ordered pairs and the slope isn't straightforward given to you. And so on a problem like this, you would need to calculate that slope. And so you need to subtract your y values and subtract your x values. So negative 3 minus 6 divided by 4, positive 4 that is, minus a negative 2. And so our slope here, if you wanted to add the opposite, you would get a negative 9. Double negatives change to positive, negative 9 over 6. For simplicity, you would want to reduce that into lowest terms. They are both divisible by 3, and so negative 9/6 would reduce to negative 3/2 as your slope. Now that you have your slope, you can write your equation. So the first option would be to use the first ordered pair. So that would be y minus 6 equals negative 3/2 times x plus 2. And I wrote a plus here because my 2 was originally negative. Now, you can also write, so we have this equation, or we can use the second equation, or the second ordered pair for a second equation. And we would have y then plus 3 equals still the same slope of negative 3/2 and x minus 4. So double checking, but the 6 in for the y spot, then -2 turned into positive, 3 went in the y spot, and 4 went in the x spot. So both of these then would be options for your equations. Example 6, use your answer from number 5 to write the same equation in slope-intercept form. So we want to convert these to slope-intercept form. So I'm going to grab this and see if I can copy over for the first equation. All right, so we're going to write or rewrite the equation. We're going to multiply this out. So the first step would be to distribute the slope times the x and the x point here. So I'm going to rewrite my y minus 6, and -3/2 times x is just -3/2 x. And then -3/2 times 2, if I made this a 2/1, my 2's would cross cancel here, and I'd be left with a -3. And so my goal, remember slope-intercept, is y equals mx plus b. I'm trying to solve this equation for y. So I want to get y by itself. So to do that, I first get rid of the parentheses by distributing like we just did. And then I need to get rid of this -6. I need to move it to the other side. And so the opposite of -6 is +6. And where would I add that? I would add it over here to this constant -3. And so then my 6's cancel. Now I'm in business. I have a y over here by itself. I have my -3/2 x. And then -3 plus 6 is +3. So that is option number 1 for rewriting. For practice, I'd like you to copy this next equation down like we just did. And I would like you to also solve this for y. So hit pause, solve for y. When you're done, hit play. All right, let's see how you did. So that first step to get y by itself, we need to distribute our -3/2. So I'm going to rewrite my y plus 3. And -3/2 times x is -3/2 x. -3/2 times -4. So again, the best thing to do here is to put this over 1. 2 cancels into 4 2 times, and then -3 times 2, or -3 times -2 would give us a +6 here. And then to get y by itself, we would subtract 3 from both sides. And again, as soon as we do that, we're now in business because we have y equals by itself -3/2 x, and 6 minus 3 is +3. And look, we now have equivalent equations, which should happen because we had the same correct answer, because these were both correct on example 5. When we rewrite them in slope-intercept form, you should get the same thing. So that is how you convert to slope-intercept form, and you'll practice that some more as we go through class. So example number 7, demonstrate how any equation in point-slope form can be rewritten into slope-intercept form using any m, or in the point 0b. Now we're using the point 0b because b is our y-intercept for slope-intercept form. So if we started with taking m and 0b and plugging it into our point-slope equation, we would get y minus b equals m times x minus 0. So this is our our point slope equation. And let's follow those same steps we just did. Those steps were to distribute our m to get rid of the parentheses. So I still have my y minus b on this side. M times x is simply mx. M times 0 is 0. And lastly, I need to get rid of my b, so I will add b over to both sides. And I can add it to my 0 over here. And so I have y equals now mx, and 0 plus b is b. So what's the benefit of point slope? If you think about the problems we've been doing in the last couple of class periods, if I said write an equation that passes through these 2 points, you could easily plug it into point slope form and distribute and have an equation in slope-intercept form fairly quickly. And so I think you will find that this is a big advantage using this format of an equation. So pretty cool stuff. Just one last tidbit here. Let's write an equation from point slope from the graph. So we're on example 8. So if I want to write a point slope equation, I need to find my slope, and I need to find the ordered pair. So the ordered pair is indicated here at this point, and that's over 2 up 4. So my ordered pair is 2, 4. My slope, I need to find another perfect corner where we cross. And my slope appears to be a positive rise of 1 and a run of 2, positive 1/2. And so then my equation would be y minus 4. I wanted to write an equal sign there. And my slope of 1/2 times x minus 2. So pretty straightforward, writing the equation from the graph. So I would like you to hit pause, find the slope and the point on examples both B and C. Try them both. Write the equation. When you're done with B and C, hit play. All right, let's see how you did. So first of all, my point here looks like 2, -1, and a slope. Let's see, I see another corner here where I'm crossing through. I have a rise of 3 and a running to the left, so that would be a slope of -3 over 1, or simply a slope of -3. So your equation you should have got was y plus 1, because it was negative, equals -3 times x minus 2. And on example C, then our equation would be, let's first find our point. Looks like -3, +4. And the slope for this line, find another point where you cross. Let's see, falling 2, running 3, and it's negative, falling downhill, so -2/3 as my slope. So then my equation would be y minus 4 equals -2/3 times x plus 3, because that was a -3 there. So that's 3 examples showing how to write the equation from the graph. And lastly, we want to be able, we have a couple of discussion questions here, and then we will graph from point slope. So how many point slope equations can you write for a line? So let's think about that. What do we need to write a point slope equation? Well, you need a point and a slope. How many points on a line is there, or are there? I would say there's an infinite amount of points on a line. So our final answer here would be that you could write infinitely many equations in point slope form, because there's an infinite amount of points on the line. You would have one slope, but you have an infinite amount of points to pick from. And that's why I have to put a point on the line for you so that we only have one answer to pick from here. In example 10, how many slope-intercept equations can you write for a line? So when I'm writing slope-intercept equations, I'm plugging in a slope and a y-intercept. There's only one of both of those, so you could only write one slope-intercept equation form of a line because we only have one y-intercept and one slope. And like I said, our last examples here. So if I'm giving you an equation in point-slope form, what I want you to do is to pull out that information that you know. So our slope here is 2 over 1, and the point given is -1. So you need to go the opposite route here for that sign. So it would be a -1x and a positive 3y, if you remember the format for your equation. So we're going to start at that ordered pair. We're going to go over to -1 up to 3. And once you plot that point, you can use your slope to graph a few more points. I just went in the wrong direction though, because we want this to be a positive 2 slope. And so positive 2, and then I could go down to the left. And so once you have several points drawn, then you can grab a ruler and draw in a line passing through those points and make sure that you have arrows on your graph. So we have 2 more examples. If you would hit pause and try both of those examples and then hit play when you're done, we'll check and see how you did. All right, so our last 2 examples here. So we have a slope of 1/2. The ordered pair we would have been graphing would have been 1, -2. So opposite signs there when you pull that ordered pair out. So we're going to go over to +1 down to -2, and our slope is a +1/2. And once you have several points drawn, grab your ruler and draw in a line with arrows. And the last example, our slope here was -3/4, and our ordered pair is opposite signs here, +3, +2. So we're going to start at 3/2 over 3 up 2, -3/4. So I'm going to go up 1, 2, 3 over 4, and down 3, 1, 2, 3, 1, 2, 3, 4. And grab my ruler and draw in my line. This concludes our notes for point slope section 11.